let's review semiconductors. So we'll go right back to the start. What we first started talking about was the three different classifications of materials. So we've got conductors, we've got insulators, and we've got semiconductors. Conductors, we know, like gold, silver and gold, they've got free electrons, they conduct quite easily, they are good for conducting electricity. Insulators like plastic, wood, rubber, stuff like that, doesn't conduct electricity because it's got no free electrons, so all its electrons are locked up, they can't move about and do anything. Semiconductors are materials that kind of conduct electricity, or conduct electricity a little bit. But as you'll see, they don't do so on their own, we need to add stuff to them. So some semiconductor devices that have got semiconductors within them, an LDR, an LED, diodes, thermistors, solar cells, all that sort of stuff we will look at, and we'll apply the knowledge that we've got just now to that. So materials that are used to make semiconductors are usually from group 4 in the periodic table. So things like silicon or germanium, those are your main sort of materials that we use for that. They have 4 outer electrons because they're in group 4. So when we bond them together, what happens is we create a kind of crystal lattice effect like this, where we've got the 4 outer electrons bonding to another 4 outer electrons next to them, so they're all locked up, the electrons, they can't move. So it basically acts as an insulator at this point in time. But we want to know that the silicon acts as a semiconductor, so it conducts in some way. So what we need to do in order to do that is to add something to it. We can do that in 2 different ways, and the process by which we do it is called doping, or adding an impurity to it. So we can increase the conductivity of the silicon by either adding an extra electron or adding the absence of an electron. So N-type conductors, that means basically there's an extra negative charge. So what we do is we add something of valency 5, something that has 5 outer electrons, so we end up with an extra electron. That extra electron can move about and it can be used to carry electricity. We call it N-type because we've got an extra negative charge. So that's one way that we can increase the conductivity of silicon. The second way that we can increase that is by adding really the absence of an electron, which is why it's called P-type, because we've got a positive charge. So we add something of valency 3, in other words one with 3 outer electrons instead of 4. So those 3 go off and bond with silicon, and then we're left here with the absence of an electron, which we call a hole, or a positive hole. So that's the shortage of an electron, and it's called P-type because we've added a positive charge to that. So that an electron from a nearby atom will move into that hole, it will leave a hole in its place, and then another electron will move into that hole, and it's basically causing the movement of this hole, or this positive charge, around there. So those are the 2 ways that we can make something that doesn't otherwise conduct a little bit. That's by either adding something with 1 extra electron or adding something with 1 less electron.